the marginal productivities of two inputs, we can also generalize. We will try to understand the differences between short run and long run. So what are the short run costs and how the output decisions occur in the short run. So then we'll try to understand these output decisions. And these output decisions, as you remember, will drive us to supply decisions, because if the firm knows for given prices how much output to produce in order to maximize its profit, then it will give us an understanding about the short run supply curve. Then we will go back to the long run and try to understand its relevance with the short run behavior. And in the long run, what will be more important is the benefits or costs of changing the scale of the production. So we will first try to understand what is economies of scale. Then the opposite will be called as diseconomies of scale. And then we will finalize this lecture by looking at what happens when some short run conditions changes. So if there's an increase in the demand in the short run, how this will result in adjustments in the long run. So how the firms react to these short run changes in the market, and how it will lead us to a long run equilibrium. Okay, so let's start with the costs. So in general, the costs are composed of two main factors. So when we have total costs of the firm, so in the previous lecture, we said that, remember that first it includes, so when we talk about costs, we mean economic costs, right? And what was the difference between economic cost and out-of-pocket payments? So what was the difference? What was the difference? Does anybody remember? Yes, so the economic costs also included the opportunity cost, because for example, by making investment in the firm, what we know that we are forgiving or foregoing some potential income that we could have earned by using this investment, for example, in the financial market, right? So if we didn't undertake any production by using this capital, we could already observe some income or some returns to this investment in the financial markets, which was given by the interest rate. But in that respect, we should also take economic costs or opportunity costs also into account. So whatever type of cost we are talking about, remember that we always include these economic costs, okay? So because they are what is important for our analysis. But if we have to make, so if we have to understand the structure of costs in the short run, then we have to make a distinction between fixed costs and variable costs, okay? So the total cost is a combination of total fixed costs that the firm has to pay, plus the total variable costs. And when we speak about fixed costs, the first thing that you should know is that in the long run, there are no fixed costs, because a long run was a period of time in which every factor could have been changed. So that so it is not a concrete period of time. So it's not necessarily 1 year, 2 years, 1 month. So it might depend on the industry. It might depend on the type of production we are taking at hand. But we can always make a distinction between long run and short run. And the main distinction between long run and short run is the fact that in the long run, we can control any type of factors of production that we would like to include in production. But in the short run, this is not possible because it is harder to implement some of these factors into production, but we can change some others, okay? For example, if you think about a restaurant, let's say, so in order to produce, I don't know, let's say some hamburgers, so you need an oven, you need a grill, you need other equipment, so you need maybe tables and chairs, and you have to make a rent payment, for example, so that these kind of costs have to be made no matter what your production is, right? So even without producing a single hamburger, you have to undertake these costs, so you have to bear these costs, so that these type of costs are called as fixed costs, okay? So again, they do not depend on the level of output in the short run, and these costs have to be borne even if there is no production. Okay, and the opposite is the variable cost. So these are the costs that directly depend on your level of production. So what would be an example of variable cost when we speak about hamburger production once again? So do you have any guess? For example, so the meat that you use, so the minced meat that you have to use in the, also the labor that you might include or you might hire can be considered as the variable cost, because if you want to produce more hamburger for a given period of time in the short run, then you can increase the amount of labor that you hire. Maybe you can do overtime work or longer period of work. So these are all relevant to the level of production that you like. So great. So in the short run, once again, so the total cost is composed of the fixed cost and the variable cost. Okay, so that we should first be aware of the fact that the shape of the variable cost might depend on the level of total fixed cost that we have in mind. And that's a good question. So a firm has to pay the bills every month. That's true. But if you consider that, so if you separate the production into monthly production, right? So once you make this rent payment, if you're doing it like every month, for example, and you suppose that your contract is for a single month, so that you renew your contract every month, right? So once you make this payment in the beginning of the month, let's say, then you cannot take back this money, right? So that you cannot change your decision. But in the long run, you can also choose what type of a place that you would like to rent, right? So how big will this place will be, correct? So then you can change these costs, and these costs will also depend on level of production that you would like to undertake. For example, if you're planning to produce, let's say, 1,000 hamburgers per day, then the place that you need might be different than a place that you would need if you would like to produce, let's say, 500 hamburgers. Okay? So then you can choose the amount of or the amount of rent payments that you would like to make, or how big your place is going to be. But in the short term, once you make this decision, then you can change your decision regarding also the rents, right? So whatever cost we are talking about, we implicitly have opportunity costs all the time, so that they're all included, okay? But the difference is actually should be clear, so that in the short run, so you can think of this as a some kind of an abstract thinking. So in the short run, you have to make these payments, right? So if you have a contract with a landowner or a landlord, then you have to make these interest payments, right? But in the long run, you can terminate this contract, or you can maybe rent another place, a franchise, for example, so that you can increase the size of your enterprise, right? So you can also change the amount of rent payments that you are making in the long run. But in the short run, we assume that you cannot make these changes. But how long is short run depends on your production. So if you're a steel factory, for example, then the long run is a longer period as compared to a, let's say, a smaller enterprise, for example, like a supermarket, I mean, or a small grocery shop. Okay. But the main difference is that there are some fixed costs that we cannot get rid of when we speak about in the short run, but in the long run, all the costs are variable. Okay. All right. So one important, as you could guess, term or definition that we need when we analyze the firm decisions is the so-called marginal cost. So when we speak about marginal cost, as you already know now, when we speak about marginal, so it means the additional effect of the last unit, right? So when it comes to marginal cost, then it is the cost of producing one more unit of output. Now let us consider our cost structure once again. So remember that the cost is a combination of fixed cost plus the total variable cost, right? So I know that this guy does not depend on the level of production, but this guy does, right? So I can also write it as a function of the level of production that I would like to take, then which means that my total cost should also depend on the level of production that I would like to take. So then how can I mathematically define the marginal cost here? So the marginal cost is the change, or I could also write D here, in total cost when I increase the production by 1. So it's the cost of the last unit that I had produced, okay? So which will be related directly to total variable cost, of course. So remember that when we spoke about the productivity, when we fix other factors, so in the short run, what we fix is all the factors but the labor input. Okay, so that's a simplification that we make. So in general, again, depending on the production structure, production technology of the firm, so what is variable cost and what is fixed cost might depend. But in general, what we have in mind is that typically labor is a part of variable cost, and all other factors are parts of the total fixed cost when we consider the short term. It is not realistic, and there are counterexamples to that, but let's live with it for a while, right? So what happens when we try to understand the productivity of labor in the short run? So what we will then see is the following. So if we have a limited place, so we discussed about this in the previous lecture, as you remember. So as I increase the amount of labor, so total product of labor for a given level of capital or other factors, right, had the following relationship. Remember in the beginning, so the total production would increase with a positive second order derivative. And no, sorry, it is actually wrong, right? So in the beginning, there was an increasing productivity. And after some point, we have seen that there is no more room for specialization, for example, then the productivity would start to decrease. And maybe if we keep hiring more people, it might also start to decline, right? So this was the total productivity of labor or total output that I could obtain when the capital was fixed and I was only increasing the amount of labor. So this relationship or this productivity schedule of the labor or the variable factors in the short run also has an influence on the cost structure of the firm. So since we are operating in a perfectly competitive environment, which means that, so this is a single firm, then whenever it wants to hire more labor, so the cost that it has to bear is the same and it's equal to W. So that there is a market wage, let's say the minimum wage, for example, or whatever wage it has to bear. And if the firm wants to hire one more labor input, then the amount of money that it has to pay is directly equal to the wage. So that the amount of wage that I pay for each unit of labor remains the same, but what changes is the additional product that I would get from this labor, right? So, and we see that after some point, after this this breaking point, which would give me the second order derivative of the total product with respect to labor is exactly equal to 0, right? Remember that at this point, the total productivity, or the marginal productivity was maximum, and the marginal productivity will start to decrease, right? So this is exactly at this point, it peaks. So then there should be different changes in the cost when the productivity of labor or marginal productivity of labor is increasing versus when it starts to decrease. Okay. Then let us try to see how it affects the marginal costs of production. So again, this is our marginal productivity schedule. When we keep other factors the same, so we cannot change it in the short run. So we only change the units of labor that we could hire. Then we argued that the marginal productivity first increases and then it starts to decrease. So what happens to marginal cost? Note that this is the cost that measured in units of output, not labor. So that the production in this site, when we increase the labor, first it increases with an increasing rate when the marginal product is increasing, so that every second labor that we hire, or the last unit of labor that we hire, actually contributes to the average production, so that it has a higher productivity, which means that producing a one extra unit of output is actually the cost of producing a additional unit of output is decreasing in this region when the productivity is increasing. But when this relationship is reversed, so when the marginal product of labor starts to decrease, so the marginal cost starts to increasing. Why? I mean, let's think about the most extreme case, so that this marginal productivity might go to 0. Then when the marginal productivity goes to 0, so the marginal cost of producing actually almost goes to infinity, because we cannot produce any more output, right? So that as the marginal product decreases, we see that producing one more unit of output is increased. Okay. So then how can we relate this to the total cost structure? Remember that the total cost was equal to total fixed cost, which is not affected by the unit of output, so that we can ignore it for a while, or maybe you can say that it's equal to 0 for a particular firm. Then or let's forget about it. Then there's also the variable cost. So what changes by unit of output is the total variable cost, right? So I can write this relation as total cost, which depends on the level of production, is a sum of the total fixed cost, which does not depend on the level of production, and total variable cost. Okay. So we had seen that the marginal cost has this U shape, right? Because in this part, we know that the marginal productivity is decreasing, and in this part, the marginal productivity is So here the marginal productivity is increasing and here it is decreasing. So how should the total variable cost look like? So in the beginning, so this is the total variable cost. So first, it is obvious that as we produce more, then the total cost should increase, or total variable cost should increase. But the question is, what is the shape of this increase, right? So in the beginning, I know that the producing, the next output is decreasing because there is an increasing productivity of labor. So then this increasing part has a concave shape because of the increase in the marginal productivity, which we could also confirm by looking at the marginal cost curve, which is decreasing in this region. So that this marginal cost, remember, the marginal cost was given by the change in the total cost with the unit of production, or the amount of production, so which was equal to FC cube plus Q. So this is equal to 0 because it's not affected by the production level. So that then this should be equal to the marginal cost, right? So that the marginal cost actually gives the slope of this total cost and total variable cost, right? So that when the slope is decreasing, you should have a concave curve. And when this slope starts to increase, then we should have a convex part of this curve. Okay. Okay. So this the marginal cost will tell us about the exact units of production that a firm would like to undertake for some given prices. But there might be different, in the short run, so there might be different profit structures, meaning that so in the short run, some firms might have very huge profits and some might have, let's say, even losses, or some might even want to say, okay, with these prices, I don't produce anything, so that they might go out of business. So when we try to understand, or when we would like to understand about the profit structure, then the quantity that we should look at is the average cost. Okay. So again, so the total cost is equal to total fixed cost plus total variable cost. And in order to understand the average cost, we should just divide these by the level of production. So that if I could divide each by the unit of output, then what I get is the average total cost, or average cost. So let's say it's average total cost, which should be equal to average fixed cost plus average variable cost. Okay. So now let us try to understand what happens with the marginal cost and average cost. So maybe it is even better to first try to understand average variable cost. Who could tell me how should average variable cost should look like when we increase production? So here I have level of production. Here I have average fixed cost. What do you think? What should I drive here? So if I had total fixed cost, I might say that it is like this, right? So this is total fixed cost. Now I am asking what should be the average fixed cost. So as a general suggestion, when you have a graph, and Burak, you're right, when you have a graph, try to give some numbers from your mind, okay? And so in order to do that, you should come up with a reference point. So you should be able to keep something constant so that you can understand what is going around. So here, what is constant, right? It is the total fixed cost. So can I give a number to it? Uh, does it require any loss of generalization for me? So can this be 100? Can this be 1000? Does it matter? Right? So then imagine that this is just a number. Then I know that there are numbers here too, right? So that what I have to draw is actually 1000 divided by Q. So this is the function that I have to derive, right? So what happens to this number as Q is increasing? It decreases, right? So it approaches to zero. So it goes to zero when Q goes to infinity, right? So that the average cost curve actually maybe starts from infinity already. It goes all the way down, right? This is average fixed cost. So Aaron asked the question, independent of production, why does it have a per unit measure? Because, sorry, Arda asked this. So Arda, the reason is the following. So I have some fixed cost and I would like to have as little costs as possible, right? So that suppose that you already rented a place, right? So if you sell a lot of hamburgers, so if you make a lot of revenues, then this amount of fixed cost starts to look more and more less, right? So it becomes very little as compared to your revenues. So in that respect, what really matters is not the absolute value of the fixed cost itself, but it is what is more important is the average level of this fixed cost, because that's what we care at the end of the day. Is that clear? Okay, then the average cost or average fixed cost was not quite hard to understand. But what is more interesting is so this was the average fixed cost. It's not a great curve, but you got the idea. But what's more interesting is the average variable cost. So let's try to think about it. So what should be the shape of average variable cost? Let's first talk about it, and then we can understand the relationship between the marginal cost and average variable cost. So what we know about the production structure in the short run is that as we would like to produce more, we know that we first face an increasing productivity for some region until some production level, and after that we observe the decreasing returns to the factors that we use in the production, right? So that I argue that when there is an increasing productivity, then the average cost should be decreasing, right? Because now, so average variable cost I'm talking about. And the reason is, as I produce more, remember that I make the same payment to the labor, for example, if this is the only variable factor that I use in the production, then as I produce more, I pay the same amounts, so the W to the labor, but what I get in return is more and more. So that the return to labor or the marginal return from labor, marginal product of labor is increasing, you should give me an increasing portion of the average variable cost. So that, and there will eventually be a reversal of this increasing returns, and eventually we will have some decreasing returns, so that argue that after some point, there should be an increase in the average variable cost. But where does this happen? For the first unit of production, what I should have is that, so the marginal cost should be somehow lower than the average cost, average variable cost. And the reason is that, for example, for the first amount of labor, so suppose that the first labor produces me 10 hamburgers, right? So it is hard to measure just by looking at the first labor that I have, but the average cost for these first 10 units is that 10 divided by W. But since I know that there's an increasing returns to labor in this first region, then the marginal cost of producing another unit of output should also be decreasing. And this rate of decrease is even lower than what I see for average variable cost. So that the marginal cost also starts to decrease. And after some point, so exactly when the productivity of labor starts to decrease, so when it goes back to the decreasing rate, then the marginal cost starts to increase. But since at this point, although the marginal cost starts to increase, but it is still lower than the average variable cost, which means that even if the marginal cost increases, as long as the marginal cost is lower than average variable cost, still the additional production, so additional unit of output that I produce, decreases the average variable cost, okay? And marginal cost starts to increase, but as long as the marginal cost, so this is the marginal cost, is below the average variable cost, so average variable cost keeps decreasing, and they become equal at some point, right? And after this point, since marginal costs keep increasing, then the average variable cost also increases with that, because now marginal cost is higher than average variable cost, okay? And this is the relationship between the marginal cost and average variable cost, okay? So then I can also bring the average total cost into this picture. But before doing it, so let's forget about marginal cost for a while. And what I know is that, let's say, average total cost, average variable cost, and so on. Okay. So what I know is that average variable cost has a U shape, right? And it is because of the changing marginal cost schedule. And what I also know is that average total cost is equal to average variable cost plus average fixed cost, right? So then I can, yeah. So then how can I derive this average total cost, right? So first, it should be affected by average variable cost. Then I could guess that the average total cost is decreasing at some point, and it might start to increase after a certain point, right? And how is it affected by average fixed cost? I know that the level of average fixed cost is ever decreasing, and it approaches to zero as I produce more and more. So since the average total cost is the sum of average variable cost plus average fixed cost, then in the beginning, so this difference gives me, so the average total cost is given by average variable cost, some average fixed cost. And it actually is a curve that gets closer and closer to the average variable cost, right? Because this difference gives me the average fixed cost, right? So because the average fixed cost is equal to average total cost minus average variable cost, so that this gap between average total cost and average variable cost should give me the average fixed cost. And since I know that as production goes higher, average fixed cost is decreasing, then this difference between average total cost and average variable cost should be also decreasing. Okay. And also, I also know I have driven the total fixed cost, total variable cost, sorry. So again, if I produce nothing, then the total variable cost is zero because it has a direct relationship between the level of output that I produce. And we have seen that the total variable cost is concave up to some point because of the decreasing marginal cost, right? So when the marginal cost is decreasing, then total variable cost has to be concave. And when marginal cost starts to increase, then it is a convex curve, right? And since total cost is simply equal to total variable cost plus total fixed cost, and remember that total fixed cost was something just fixed, then this difference between total cost and total variable cost should give me exactly the amount of total fixed cost. So it doesn't change, right? But the shape is preserved between total cost and total variable cost because the shape is solely determined by the changes in quantity and its relation to total variable cost, so that the shape of total cost and total variable cost exactly the same, but it is higher since there is a positive total fixed cost. And if there were no total fixed cost, so if the total fixed cost was zero, then total cost would have been equal to total variable cost. Okay. Now, let us bring marginal cost and average cost together, and then let's talk on it a bit. So what I want to drive is average total cost, average variable cost, and forget about average fixed cost for now because I know that is the difference between average total cost and average fixed cost, average variable cost. And what I want to bring into picture is the marginal cost now. So when you drive these kind of graphs, so the simplest way is to start with marginal cost. And I know that it has this nice U shape, right? Okay. So now I would like to start with average variable cost. So what I know is that it should be decreasing as long as it is above the marginal cost, and they become equal exactly when the average variable cost reaches to its minimum. Because I know that as long as marginal cost is below the average variable cost, so average variable cost should be decreasing. And after this point, this marginal cost is higher than the average variable cost, then average variable cost also starts to increase. And I also know the relationship between average variable cost and average total cost. So it also has this relationship. And the gap between, okay, it's not a good one. It starts like this, and again reaches the minimum when it is equal to marginal cost. And the gap between the average variable cost and average total cost is zero when Q goes to infinity. Right? Okay. So now, again, in the last lecture, we had seen that if there is no fixed cost versus variable cost distinction, so when we talk about the long run, we could understand the optimal allocation of resources from the firm side across different factors of production, and we specifically talked about the capital and labor. But now, in the short run, so decision of the firm is somehow different because the capital is now fixed, right? And what the firm can choose is the amount of labor. And once you know the amount of labor, then you can also have a control over the quantity that you would like to produce. But the objective is still the same. So the firm wants to maximize the profits for given price levels. And when we talk about short run, it also knows the capital level, which he had decided in the past already, and it is fixed for this period of time. So what is important in our analysis was this so-called perfect competition, because we still assume that we are in a perfectly competitive market. And when we spoke about the perfect competition, what we had in mind is this so-called price-taking behavior. So a perfectly competitive market or a perfectly competitive industry would mean that there are way too many firms, so that each firm is kind of atomistic, so they are very small to be able to affect the market prices alone. And we also assume that they are producing exactly the same output when we are talking about a particular industry. So that this perfect competition assumption would bring us two main things. First, all the firms are price taking, so they observe the prices in the market and they take these as given. So these prices were the price of the output and also prices of the factors, namely the wage and interest rate, or the price of other factors that it might be using. So another result of perfect competition is that, or another assumption that we make regarding the perfect competition is that at least in the long run, new firms can enter the market and other firms, so the old firms that are already operating in the market, can exit. But these things happen in the long run. So in the short run, we assume that there is no entrance or exit from the market. Okay. And one important assumption to that is homogeneous products, so that everything that's produced in a single industry should be exactly the same, so that the products are not differentiated, so that you cannot distinguish the product of a single firm from the product of some other firm. So once we have this structure of industry, when we have a perfectly competitive market or a perfectly competitive industry, then we can drive the profit of a firm. So remember that the profit was given by the difference between the total revenue minus the total cost, right? And so now we have understood in the short run how total costs look like. It depends on the level of production, and we know how the shape of this production looks like. And total revenue is even simpler, because in a perfectly competitive market, what we have is that there is a price that happens in the market, right? So that the single firm who would like to maximize the profit, observes this price and has no control over this price, but what it chooses is the level of production. Okay. So now we can make a definition of marginal revenue. So the marginal revenue is simply the change in total revenue when we increase the level of production by 1. Okay. So if the price is given, so if the price is not affected by your level of production. So what can I say about marginal product? What should it be equal to? What do you think? So once again, marginal revenue is equal to change in total revenue when I change the production by 1 unit. Or if you like, so if there's a continuous relationship, then you can also say that it is the derivative of total revenue with respect to quantity. So if the price is fixed, so if the firm cannot change the price, what should this be equal to? Yes, exactly, to the price, right? So if I sell another unit of output, then the money that I get for this output is exactly equal to its price, because my level of production does not affect the market price. So that when we speak about perfect competition, this is the equivalence that should have to come to your mind, that the price is equal to marginal revenue. Okay. Right. So that once again in the market, there is an aggregate supply. So this is sum of supplies from all individual firms, and there is some kind of aggregate demand, right? And when they come together, there's an equilibrium price that happens, but the demand curve is a single representative perfectly competitive firm. So this is a single firm. What the firm observes is that no matter how much I produce, so say that this quantity, no matter what I produce in a perfectly competitive market, I will be able to sell exactly at the market price. So even if I produce infinity, I assume that I can sell all these products if we are talking about a perfectly competitive market. Okay? So now let us try to understand how the firm can decide the production level. So now the objective of the firm is to maximize profit, which is given by the total revenue, P times Q, minus the total cost, which is also a function of the quantity that it produces. And what is the choice variable in this time? What does the firm chooses? It chooses Q. Okay. So in the short run, all these constraints are included in the total cost function, because when we derive the total cost function, we already take the fixed scale, so the fixed amount of capital already into account. So this embedded in my total cost function, so that there's as if no constraints, right? So we can easily derive now the profit maximization rule, which is simply given by the derivative of the profit with regard to the only choice variable now I have, which is the quantity. And what is it equal to? So here it is equal to price, or in general, if I had written as total revenue, which depends on quantity, then it would be equal to the marginal revenue, right? Which is equal to price in a perfectly competitive market. And it should be equal to, and there is also a derivative here. And what is the derivative of total cost with respect to quantity? So what is this guy? Yes, and how can we call this? So this is total revenue. It is average total cost. Average should be given by the total cost divided by quantity, right? It is marginal cost of production. So if the derivative of total revenue is marginal revenue, then the derivative of total cost should be equal to marginal cost. Then it should be equal to what? If I want to find an optimum, it should be equal to 0. Then I can say that if I would like to have a profit maximization rule, then in general, no matter the market is, in general, the principle is that marginal revenue has to be equal to marginal cost. But in particular for perfectly competitive markets, since I know that price is equal to marginal revenue, then I can also say that the profit is maximized when marginal cost is equal to price. Okay, so this is the profit maximization rule for a perfectly competitive firm. Now the question is it a sufficient condition or is it a necessary condition? What do you guys think? Or Eren says that it's necessary but not sufficient. But I'm asking, so for profit maximization, we derive the first order condition, right? The first order condition tells me that marginal revenue has to be equal to marginal cost. And since I know that marginal revenue is equal to price in a perfectly competitive market, then it should be equal to marginal cost. Okay, but let's drive this, right? Like graphically. So what I know that the marginal cost, so this is quantity, and this is the same marginal cost and the price level. So I know the marginal cost curve, right? So it has this shape, right? And there's a market price that the firm takes as given, it observes from the market. So the price level is given by, let's say this is P star, so the price in the market. And I also know that since this is a perfectly competitive firm, so that it can sell all the products at this market price, right? But this is also equal to marginal revenue, right? So where does this profit maximization quantity determined? When marginal revenue is equal to marginal cost, which is this particular point, right? So then this is the quantity that I would like to produce in order to maximize my profit. Now the question is the following. This condition, marginal revenue equals to marginal cost. Is it a necessary condition? Or is it a sufficient condition? Alperen thinks it's sufficient. Eren says it is necessary but not sufficient. Ahmet says it is necessary but not sufficient. So, Eren and Ahmet, why do you think that it's not sufficient? So in a perfectly competitive market, Eren also change. No, Eren still says it's necessary. Okay, real life, not sufficient. I mean, in real life, nobody makes this calculation anyways, right? Okay, maybe I give you a hint. So now this is the price level, and it's equal to marginal revenue. So the question is, what is the profit maximizing level? Is it Q1 or is it Q2? Exactly, Alperen. That's the reasoning. You're correct. So where does it lead us to? So Alperen says that if price, so in this case, it's also the marginal revenue, is higher than the marginal cost, so if the marginal revenue is higher than marginal cost, then it says that I would like to produce more, because by producing more, I am increasing my revenue. My costs are also increasing, but increasing the revenue is higher than the increase in the cost, so that I should produce more, right? Because by producing more, I get more revenue than my increase in the cost, right? So that it makes sense if I keep increasing my production, but what I know that marginal revenue is the same for every level of production, but what happens is that marginal cost is increasing, so that then, according to this logic, I have to stop exactly when marginal cost is equal to marginal revenue. Because if I keep producing, then marginal cost is higher than marginal revenue, so that the producing more should decrease my profits, right? Correct? That's what you say, Alperen, right? So then, is this point optimal or not? So it satisfies the condition, the first order condition, marginal revenue is equal to marginal cost. So it is also satisfied here, marginal revenue is marginal cost, but there's a difference. Here, marginal revenue after this point is higher than the marginal cost, so that I should keep producing here because it increases my profit, right? So let me drive this a bit differently so that we can understand. So quantity again. Now, instead of marginal revenue and marginal cost, I will drive total revenue and total cost, if it is fine. So we have total revenue and total cost. Okay. So we have seen the total cost, but we have not seen the total revenue. So how can I draw the total revenue graph? Is it increasing? Is it decreasing? Is it linear? Is it non-linear? What do you think? So what was total revenue? It is increasing, so it was P times Q, right? Exactly. So it's a linear line which has a positive slope which is equal to P, right? Okay, that is perfect. So then this is my total revenue. Right. So now for simplicity, let's assume that there is no fixed cost. So it is equal to 0 without loss of generality. So that the total cost looks like the following. It is first concave, right? Then it is convex, right? So this is total cost. Okay, it's not perfect, but you get the idea, right? It's like positively sloped everywhere, but the slope is changing. Okay. So what is profit? Profit is equal to total cost minus total revenue, right? So here, what is profit? Alperen says no. Oh, no, you're right. Total revenue minus total cost. Thanks. Okay. So here, let's see. What is profit? Is it positive or is it negative? It is negative, right? Because total cost here, or maybe let me try to draw it with a different pen. Yeah. Okay. So here it is negative. And here, so in this region, it is positive. At these points, what is profit? It is 0, right? Okay. So what I am trying to find, I would like to find the maximum profit. Where does it happen? It happens somewhere here, right? So that the distance between total revenue and total cost gives me the profit, and I would like to maximize this profit, right? So how can I find it? So how can I find the maximum distance? I think the easiest way is to draw a line that is parallel to total revenue, right? And it's also tangent to total cost. And when they are equal, then I can find the maximum distance, right? So it is basically equal to derivative of difference function, if you like. So then you can also think that, okay, if I would like to drive the profit, then what I know about profit is that, okay, it's not a good one. Does it work? No, it doesn't work. This one? Yeah, it works. Okay. So the profit looks like the following. So it is negative, it is increasing. I mean, like it's more negative. It goes smaller, it becomes 0. And it is increasing, it becomes 0 again. So this is a profit, right? Yeah. So what I would like to find in this point, which is exactly the same as here. So what I'm trying to find is that the derivative of the profit is equal to 0, right? So at this point. And I found that it's given when marginal revenue is given equal to marginal cost. So this slope of total revenue was marginal revenue, and the slope of total cost was equal to marginal cost. But in this graph, how many points are there that satisfies this condition? Right? One is here and one is here. Correct? But only one actually maximizes profit. What does the other one does? Yes, it minimizes profit, right? It maximizes the losses. Yes. So now back to the question. Is this condition necessary or sufficient? It is necessary, however, it is not sufficient. For it to be sufficient, I need another condition, which is the second derivative has to be what? Positive or negative? It has to be negative. I mean, you had 50% chance, right? So what to do? So now you think about why it is negative. So in order to do that, you should think, what does the second derivative mean, right? Then you will understand why it is supposed to be smaller than 0. So you are trying to memorize, which is not good. So you have to understand the logic. And you can understand the logic by looking at this, okay? Then we will continue. So now we understand that the profit maximization rule, or the profit maximization decision, require us to have a equality between the marginal revenue and marginal cost, so which determines the level of output that the firm, a representative firm, would like to produce, right? So there might be some changes in the market in the short run. So the demand, for example, might change, which can drive the market price to a higher level. So what happens then? So as the price goes up with the increase in the demand, so the quantity that would like to be produced by the firm also increases. And then we see, if we combine all this increase in the production by all the firms, then we also see that quantity supplied in the market also increases, right? So in the long run, the output decisions are somehow different. So remember that the difference between the short run and the long run was that in the short run, some factors were fixed, so that we could change the level of output by only playing around with the variable factors. So that in the short run, we could see that some firms might earn exactly in the short run, firms might have some positive profits, including zero profits, which we call as break-even point. So some firms might observe some losses, but they still might want to produce in the short run in order to minimize these losses. And some of the firms might find it optimal not to produce at all, but even if they don't produce, they still have to pay for the fixed cost that they have observed, right? But how can we understand these situations? So maybe let me try it once again. Oops. I don't like it. Okay. So let's say that price level occurs at such a point. Okay. So then what I know So this is, let's say, price level 1. So in this price level, I know that the optimal production at this level, let's say Q1. And here, like this, actually. So at this level, I can find the profit, which is the difference between total revenue and total cost, right? Remember that total revenue was equal to P times Q. So here, the total revenue is given by the square, right? Because it is equal to Q1 times P1. And how can I find the total cost? So the total cost is equal to what? Average total cost times the quantity level. Because average total cost was defined as this, then I can find total cost as average total cost times quantity. So what is the average total cost here? So if I look at this point, then I know the level of average total cost. So then this lower square gives me the total cost. And the difference between total revenue and total cost, which is this part over here, right? So this gives me the total profit. So this is one case that can occur in the short run. Now let us consider another price level. Let's say the price is exact, or let's use this one. The price level is such that it is exactly the same as the average total cost. So let's say this is P2. So what is total profit in this case? Right. So this is total revenue. But what is total profit? So this part is total revenue, right? Then I have to find the total cost at the same time, which is equal to, so at this quantity, the average total cost is equal to this point here. Then I can find the total cost, this is attached to this production level, which is equal to average total cost times the quantity, right? Which is also equal to the total revenue, right? So what is total profit in this case at this price level P2? It is equal to 0, and that's why we call this point as break even. And the reason is the following. Remember that when we have costs, we also include the economic costs, so that although total profit is equal to 0, actually, if you would look from an accounting perspective, there should be some profits, positive profits, which are exactly equal to the opportunity cost, right? So that by at this point, firms exactly break even, so that they actually observe a revenue that matches their total cost, which also include the concept of opportunity cost. So that at this point, the entrepreneur is okay with making production, right? So, but the question is, what happens if the price level in the short run is lower than this break-even point? So, for example, let's say the price level is lower than this P2 level. Then, still, the profit maximization rule tells us the optimal production is at Q3, right? And what is total revenue? So let me leave this guy. So this portion now, so this guy over here, maybe it's not easy to see this. It's this guy. So this is total revenue, right? And how about total cost? So at this Q3 level, so here is the average total cost. Then this gives me the total cost. And in this case, when prices is P3, then what I see is total revenue is actually smaller than the total cost. The question here, should the firm keep producing or should it close the doors and it should say, okay, I don't produce anything, but I have to bear the fixed cost of production, right? Because these are the payments that I already make, but in the short run, I cannot take them back. So what do you think? Should the firm produce this amount, although there are some losses? Or should the firm say, okay, I don't make any production? There are no preferences, Alperen. When we speak about firms, so if there is no demand, so if there is no household, then there are no preferences. So what matters for the firm is only the profit maximization, okay? So it would like to make, yeah, okay. In the long, so we will speak about long run, but now we are in the short run. So you cannot take back your fixed costs, right? What you can change, you can determine your production level. So then if the prices are equal to break even or higher than the break even point, then there are positive profits, which means that the firm would find it optimal to produce. But what happens if the prices are lower than this level? So now let us consider the following. So if you don't make any production, so let's think about it. Or maybe let me draw it once again so that we see it more clearly. Oops. So the price is at some level here, right? Say P3, then I know that this is Q3. And I know that the total revenue is equal to this area, which is P3 times Q3. Okay, so if I don't make any production, what is my cost? It is equal to total fixed cost, right? And how can I find total fixed cost? It is equal to total cost minus total variable cost. And what is it equal? So I can find the total cost by multiplying Q3 times this guy over here, right? Minus Q3 times average variable cost at this level, right? So then the total fixed cost is given by this rectangle here, correct? So this is total fixed cost. Now, this is the cost, so this is the loss that I have to bear if I don't make any production. What happens if I make the production? If I make the production, then I can get this revenue over here, right? So this is total revenue, and total cost is this rectangle here. Then the total loss is the difference between total revenue minus total cost, right? So that the total loss, if I make production, is now this little rectangle here. So in this case, is it optimal to make production or is it not? I think Ahmed have the correct answer here, right? So that in this case, the firm cannot make any profit, but now in order to minimize losses in the short run, you have to keep production, right? In the long run, you might say that, okay, I mean, I'm not good for this business, so that I have to close my doors. So in the long run, you can shut down, but in the short run, in order to minimize losses, you have to keep up with the production. Then, what is the minimum point that the firm should still do some production? It is given by this point over here, right? It is the minimum of average variable cost, so that if the prices is equal to this shutdown point, then it is still optimal. If it is equal to shutdown point or it is above the shutdown point, yes, this is exactly this point. So this point we call shutdown point. And why is that? So here, let's consider here, so the fixed cost is equal to this area here, right? So if I make the production, then the total losses will be exactly the same as total fixed cost. Then at this point, I am indifferent between making the production and having loss of this area, or I may not make any production and my costs are the same. So that at this shutdown point, the firm is indifferent between performing any production or not. But if the price level is smaller than this level, then it is more optimal for the firm to shut down, just bear the fixed costs, because if it produces, the losses are even higher than these fixed costs. So that's why we call this point as shutdown point. Then actually, the firm makes a positive supply for prices which are higher than this minimum price level, so the shutdown level. So, and this part constitutes the individual supply of a competitive firm, which is also shown in this graph. So this is the short-run supply curve. Okay. So this is a typical supply curve that we observe in our analysis. So, and how can we drive the short-run supply for the industry? We simply sum them, sum the individual firm supplies in order to drive this industry supply curve for the short run. So, this is for the short run, okay? And what happens in the long run is somehow different, because in the long run, there is no reason to, I mean, we can change every factor that we can implement in the production. So we can also choose our capital level or the scale of our production, so that there is no fixed cost in the long run. And in that respect, and so that's the one thing about the long run. And the second thing is that if there is a positive profit in the short run, so what happens in the long run is that since there are entries or exits to the industry in the long run, so if there are positive returns in the market, so then there will be more firms in the long run who would like to produce and who would like to take some of these positive profits from the market. So what happens if more firms enter to the market, then these positive returns should decrease because there's more and more firms who would like to take out from these excess profits. Then we would eventually go back to a break-even point. And if there are losses, whether they are minimized or not, so it doesn't matter. So some firms will exit from the market, right? Because they wouldn't like to have negative returns. And what happens again, that the industry goes back to the break-even level in the long run. So the most important subject when we speak about long-run cost is the so-called long-run average cost, which tells us the way per unit costs change with output in the long run. Remember that in the short run, when we derive the average costs, okay, they would depend on the production level, but they were solely determined by the variable costs because we couldn't change the amount of other factors that we would like to implement in the production. But in the long run, we can change everything so that the shape of average cost or the decision or the way that the long run average cost takes its shape is also affected by the change in other factors, which we call as the change of the scale. So the scale of a production simply means, so suppose that I produce an output called Y, and I have a particular production function which is given by F. Okay? So increasing scale of production. So remember that in short run, I keep capital fixed, and only factor that I could change was labor. Okay. But in the long run, I can change both. And since I can change both, what I look at is the change in output when I change the factors of production proportionally. Okay. So this change in the this proportional change is called as change in scale of production. Okay. So for example, if I use let's say 10 units of capital and 50 units of labor. So when I say that I double the scale, then what I say that I use 20 capital and 100 labor. So that in this case, in this scenario, lambda is equal to 2. Okay? So then three things might happen to the long run cost structure. So first, when I increase the production by lambda, then my costs might decrease because of this increase in the scale, so that I produce in a different scale now, right? So increasing scale means that I use all of the factors proportionally with a higher amount, and then what happens to my long run cost is my concern. So one thing that could happen, this increase in the scale might decrease my long run cost. So maybe, so if I'm operating in a higher scale, maybe I can obtain some of the inputs for cheaper prices, for example. I don't know. But if the costs are decreasing as the scale increases, then we say that there is an increasing returns to scale. Okay, then it also means that the change in Y is actually higher than lambda. So we can say that K then is higher than lambda times this original product. Okay, so in this case, we have increasing returns to scale, or in short, we call it IRS. The second thing that our production costs in the long run may not be affected by the scale of production, then in this case, we have constant returns to scale. which also means that if I increase the scale of production by lambda, then it is exactly equal in the increase in the production level. And the last case, we might have decreasing returns to scale. So if we are talking about the change in scale, so it means that we increase capital and labor at the same amount. And the reasoning behind this, Eren, is the following. So in the previous lecture, we have seen that so this capital and labor ratios are chosen optimally. So in the long run, since I can change all the variables, then it means that I should always choose the allocation of capital and labor optimally, so that what should I be considering is a proportional change in capital and labor. So when I make this consideration, so this is as if a thought experiment, right? So I'm not saying which one is optimal for now, right? But what I'm saying is that what would happen if I change my capital and labor proportionally? So that it means a change in the scale, and in that respect, I should look at a proportional change. Is that clear? Okay. So the last case can happen that increasing the scale of production might lead to a increase in the costs, long run costs of production. Then we call that it's a decreasing returns to scale, which means that when I increase the scale of production, then the increase in production level is even lower than a proportional increase in the output. So that I, for example, double the factors of production, by my output increase less than double. Okay. So what is increasing returns scale and why it may not occur, right? So the one thing that could happen is that when I operate in a larger scale, so when you compare a supermarket chain versus your local grocery shop in your neighborhood, for example, right? So this increase, so we might think, if we compare these two, we might think that they operate in different scales, right? And for these guys, we could also think that the production technology is different because they make use of, so if you consider the supermarket chain, for example, so they can make use of different supply chain operations. So they might have their own truck, for example, and which might decrease the costs of production, right? But this kind of decrease does not only have to come from the technology, but there might be also a firm level efficiencies, such as a better management, for example, or a more efficient use of labor in the market. Or it might also lead to a bargaining power that, you know, if you hire, let's say, 50 people instead of 2 people, then you might have a higher bargaining power as an entrepreneur as opposed to your small grocery shop, right? But whatever the reason, so if there is a increasing return scale, what we mean that if you operate on a larger scale, then your costs of production are lower. So that one terminology that we can use is the minimum efficient scale. So it means the smallest size at which the long run average cost is at its minimum. So that typically when we consider the long run average cost, what we would like to observe, or what we expect to observe, is the following. So that there should be a decreasing part. And so sometimes it might make a plateau that, you know, some different scales of production may lead to the same amount of long run average cost. and then we will see an increasing portion of the long run average cost. So here, since I am talking about long run, increasing production only can happen from increasing the scale of production, because in the long run, I can change both capital and labor, right? So what happens here is that as I increase my scale of production, what I see that long run average costs are decreasing. So this part, what we observe is increasing returns to scale. So here in this plateau, or in this bottom, what we see that increasing returns does not change my long run cost structure, and hence here we have constant returns to scale, and on the right hand side we have increasing costs with the scale, hence we have decreasing returns to scale. Okay. So here within the long run, we might see infinitely many short runs, and each short run curve might correspond to a different level. So that actually this long run average curve is a collection of these infinitely many short run curves, and so this curve is also called envelope curve from time to time, and the reason is that it is actually tangent to all these points of short run average cost curves, and it collects all these tangent points and it draws the long run average cost curve. So that each short run here corresponds to a different scale, since we have already discussed that in the short run the scale of production is fixed because some factors are fixed, and we can only change one variable. So thus, the short-run optimization problem is somehow different from the long-run optimization, because in the short run we can only play around with a limited number of factors of production. Okay. So then the optimal scale of plant is given by the minimum long-run average cost curve. So this minimum over here, and also at this point there should be a corresponding short-run average cost, so that when we consider a firm in the short run that operates in the optimal scale of plant, so we think about this firm which has this short-run average curve, and it is minimum is equal to the minimum of long-run average cost curve. Okay. So what happens if there is a change in the short run, right? So there is a short run increase in the demand, which means there is a positive. So if this price level is higher than the average cost level, when the marginal cost equal to price, then there is a positive return that we observe here, right? Maybe let me zoom in a bit so we can see it more clearly. Okay. Okay, so here is a positive profit. But what happens then if there is a positive profit in the short run? So in the long run, there will be more firms to enter into the economy, right? So, and what do? So they increase the industry supply from S0 to S1, which drives back the prices to the original level. And in return, now there are more firms because there was a higher demand in the short run. So in the long run, there are more firms. So in the beginning, we had 100 firms, but now we have 120 firms. But the long run structure actually comes back to this optimal scale of production, because in the long run, all of the firms have to choose this optimal scale. What we observe here on top of it is the following. So in the long run, we are not only operating on the minimum of the long run average cost curve, but it also corresponds to the minimum of short run average cost curve of each firm. Remember that at this minimum, what we have is that price is equal to marginal cost, which is also equal to average cost. Now we also say that it is equal to long run average cost, right? And if price is equal to average cost, what is the profit in this case? What happens if the price is equal to average cost? So I know that in a perfect competitive market, price has to be equal to marginal cost. But in the long run, what I also know that price is also equal to average cost because it corresponds to this minimum level. And remember that the profits were given by total revenue minus total cost, right? And total revenue is simply equal to marginal revenue or price times Q. And total cost is average cost times Q, right? So if price is equal to average cost, then it means that total revenue is also equal to total cost. Then total profit, economic profit, is 0. So in the long run, what we see that if the market is perfectly competitive, there is no excess profit in the long run, and hence every firm operates with break-even point or 0 economic profit. And in the long run, on top of this equality, so the whole equality actually tells us the following: in a perfectly competitive market, price is equal to marginal revenue, and for profit maximization to happen, it should be equal to marginal cost. And in the long run, this marginal cost will be exactly equal to short run average cost. And since the scale will be optimally chosen, then it will also be equal to long run average cost. And it also says that there is no excess profit in a perfectly competitive market. All right. So there's where the efficiency of perfect competition comes from. This is it for this week, and I am looking forward to seeing you next week. All right. Thanks a lot for